Alright guys, so we're going to talk more about the exponential function here. Let's start off with this important property that we spoke about last time, which was, remember, the exponential function, they're all one-to-one. So for every unique x input that you put into the function, there's some unique output y. So what does that mean? That means if you have 2 raised to some exponents to some power, maybe it's like 3x plus 1, and it's equaling 2 raised to some other exponent like 15 plus x squared. That means, because these functions are one-to-one, that means this exponent and this exponent have to be the same because their base is the same. So whenever you have the same bases that equal each other, that means their exponents are the same. So you'll see how this plays out and why that's so useful as we do these below examples. So let's look at the first one, which is right here. We have 2x to the 8th. How can we figure out what x is equal to? Well, one thing we can do is we can rewrite 8 as in exponential form, if you want to think about it like that, with a base of 2. So I know I can rewrite 8 as 2 raised to the 3rd power, right? Because 2 times 2 times 2 equals 8. So I can rewrite 8 as 2 to the 3rd power, and then on the left-hand side I have 2 to the x. On the right-hand side I have 2 to the 3rd. So because these bases are the same, they're both 2, I can just equate their exponents. So that means x equals 3. All right, so once you get their base to be the same, you can equate the exponents. And that's an easy way to solve for x. Now obviously that was a very trivial example, but we'll get into more fun ones in a second. All right, so here's another one. We have 3 x minus 5 equaling 9. So whenever you have a question like this, the first thing you want to ask is, how can I write both sides with the same base? Well, I know I can write 9 in terms of 3, right? Because I know 3 squared is equal to 9. Once I have the same base, I can use the one-to-one property and say that means their exponents must be the same. So what is x then? Let me make this a little bit smaller. What is x then? If I add 5 to both sides, I get x equals 7. See, it's not bad. Let's do 2 more just like this. All right. So now we have 1/2 to some power equals 8. Now, anytime I have a fraction, what I like to do is I like to rewrite it so that I have, oh gosh, my cat is coming in. She's about to wreck everything. Miley, go away, go away, go there. Okay, so anytime I have a fraction, I try to get this guy, the denominator, back on top. So I want to rewrite this as 2 to the something power. But because I switched this 2 from the denominator to the numerator, I have to throw a negative in front of my exponent. Remember we said that, I think, in the last lecture? Yeah, anytime I switch from the numerator to denominator or denominator to numerator, I throw a negative sign in front of my exponent. So that's what I did here. Instead of saying 1/2 to the x, I'm saying 2 to the minus x. Okay, they're equivalent. So what does that mean? I have 2 to the minus x equaling 8. Now I can look for an easy base. And the base here that we're going to be looking for is 2. How can I write 8 in terms of 2? In terms of base 2? Well, that's 2 to the 3rd. So because now my bases are the same, right? I have a 2 right here and a 2 right here. We should probably make that smaller as well. I can now equate their exponents. So I'm left with minus x equals 3. That means x equals minus 3. So what we just solved for is we're saying that 1/2 raised to the minus third is equal to 8, which makes sense if you remember what we did in the last video. Okay, last one. So same thing happens. We have a fraction here. I want to get that 3 in the numerator. So what I'll do is I'll create a base 3, but because I put them in the numerator, I took them from the denominator to the numerator, I'm going to put a negative in that exponent, minus 2x. And now my goal here is to write 27 with a base of 3. So 3 times 3 is 9. 9 times 3 is 27. So 3 to the third equals 27. Okay, good. Again, we have the same base here and here. So now I can equate their exponents. Minus 2x equals 3. Therefore, x equals 3 over minus 2. This minus can be in the top or bottom or whatever. Don't worry about the placement of that negative. It's not that important. But know that it is negative, right? I get that question a lot in class where people are like, should my negative be in the numerator? Should it be in the denominator? Or should it be just out in front of the number? All of these represent the same exact thing. So don't worry too much about it. Just make sure that there's a negative somewhere in there. All right, good. So hopefully you got a good understanding on that. Let's talk about the next thing about exponential functions. If I can get this to zoom over, good. So remember, again, exponential functions are one-to-one. That's exactly what we did up here, and that's why we were able to compare exponents. The other thing that's special about one-to-one is that they pass the horizontal line test, and that means that our exponential functions have inverses. Okay, so let's review what inverse function means. It means this. A function takes something from my domain, I put those x's into my function, and it creates some y value. Oh god, it creates some y value. So for instance, let's say like 2. And I have a function f of x equals 2x plus 1. So, oh, well, let's do a different one. Let's say 2x. So that means if I take this number from my domain and I put it into my function, the y value that will come out is 4, right? Equals 4. So it becomes 4. So 2 put into my function turns into 4, right? It's been transformed, if you want to think about it, into 4. So what does the inverse function do? Well, the inverse function, what it does in this case is that it takes this 4, puts it into our inverse function, and it sends it back to 2, right? So this guy right here represents inverse function. It's f, but it has that minus 1 on top of it. So instead of taking the 2 to 4, my inverse function will take 4 back to 2, right? So if my inverse function looked like this, and I plug in 4 into my inverse function, boom, 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 it'll send me back to 2. So we were kind of undoing what the first function f did. We're kind of undoing it if you want to think about it like that. Okay, so now we got to remember how to find inverses. So let's come to this guy. Find the inverse of this function. So if you remember our steps, I think this is how we did it in class. I'm pretty sure is we turned f of x into y, and we kept the right hand the same. And now our goal is, currently we have y isolated all by itself on one side. Our goal is to isolate x by itself. So the first thing I'll do is I'll take 1 from both sides. So I have y minus 1 equals 2x. The second thing I'll do is I'll divide out by 2, because that's the only thing attached to my x that's left. Divide by 2. So I have y minus 1 divided by 2 equals x. And the thing here is, just like how y was rewritten as f of x, right? Y was the nickname for the proper name f of x. X here is the nickname for what we're going to write proper as f inverse. That comes from the notation right here. F inverse of y. Now y, see in the top part, it was f of x. And in this part is f of y. Why is it y here? Well, if we look at this top statement where it's f of x, everything on the right-hand side has an x in it, right? There's no other variable on the right-hand side in our equation. And same thing goes here. If I remove this little x right here from the picture, and I just draw a giant equal sign, I have f of y, and everything on the left-hand side has a variable of y in it. This is why it's f inverse of y and not f inverse of x. If you wanted to write f inverse of x, you'd have to change both of these variables on the left-hand side and the right-hand side, like that. But in my opinion, I don't really like that notation, only because it makes this picture more confusing. We forget what x is, we forget what direction we're moving. But I've seen it taught both ways, so it's up to you. You guys get to pick. Okay, so let's do another one. All right, so we have f of x equals 3x minus 14 divided by 2. So first step again, rewrite it as y equals 3x minus 14 divided by 2. First thing I'll do is get rid of this denominator 2. So I'll multiply both sides. I'll multiply both sides by 2. So when I multiply by both sides by 2, these 2's cancel out. So I have 2y equals 3x minus 14. Now, let's get rid of this 14. If I add 14 to both sides, plus 14 plus 14, then these 14's will cancel out, and I have 2y plus 14 equals 3x. Lastly, 2y plus 14, get x by itself by dividing both sides by 3. So I have x equals 2y plus 14 divided by 3. And now we're just going to rewrite x into its real name. Which is f inverse, right? We're saying that the function that we've written on the left-hand side of this equation, of this equal sign, is the inverse of this original function right here. So this is the inverse function of f, and it has a variable of y, right? It takes in a variable of y. Okay, this should hopefully be a review, but it's important for our lesson. I wonder if you guys can hear my cat yelling. All right, anyway, she's only 5 months old, so you gotta be patient with her. All right, so the last one. We have f of x equals 2 to the x. So what do we do again? We say y equals 2 to the x. We change f of x to y, and now what do we do? I can try dividing by 2. Well, that doesn't really help me. I can try multiplying by 2, that doesn't help. Subtracting, adding, none of that really helps. You see, no matter what operation I do, that x in the exponent, I can't drop down. That x in that exponent is my problem right here. See, if I had something like this, where x was my base, then I can start undoing the square and having a base of x. But because this x is stuck in the exponent, I know I have nothing that can bring it down. Do you guys understand? So this is where logarithms come in. Logarithms are going to help me bring down this exponent and help me solve for these harder, in a way, inverse functions. So let's do that in the next video. Okay, we'll start talking about logs there.